Okay, our next example is, if you could see, this is already in the standard form. And this standard form is in linear in x because we have dx over dy and we have our p of y and q of y. So what we need to do here is just to solve this one. So let's try copying. We copy the given. We have dx over dy plus x 2y equals 5y e raised to the power of y squared. Okay. So let's try to solve. So in this case, we already have our p of y. Okay, we know that this is p of y because we are in linear of x. Obviously, you have dx, you have x here. So what remains is another variable that is y. So that is 2y. Sir, could we use only y? Include the constant because remember that the standard form in this side is just x. So other than x, that is your p of y. Then your q of y will be 5y e raised to the power of y squared. So now, this is our need to remember this one because later on we will substitute this one. Okay. Sorry. Okay. So now let's continue. So from here, we can now get our integrating factor. So get our integrating factor. So our integrating factor is still e raised to the power of integral of py. So py dy. Sorry. So we have integral of py dy. Okay. Now, so let's continue. So you have integrating factor is equivalent to e raised to the power of the py is 2y dy. So therefore, you have e y dy, or you will have e raised to the power of 2. Integral of y is y squared over 2. So we could cancel this 2 and this one. So your integrating factor is equal to e raised to the power of y squared. Okay, so that is your integrating factor. Okay, so that is your integrating factor. So from there, we can now use your general solution. So if you could still remember the general solution for linear in x, because here this is linear in x because we have your dx, dy, and this is our py, and this is our qy. So we have linear in x. So if it is linear in x, it's simply x times integrating factor equals integral of q of y times integrating factor dy plus c. So from there, just substitute x times what is integrating factor e y squared. Very good. Equals integral, what is q of y? That is 5y y e raised to the power of y squared. Then times integrating factor, that is e y squared. Then dy plus c. dy plus c. So from there, we just combine what we can combine. So you have x e y squared equals, so e raised to the power of y squared times e raised to the power of y squared, that will give you, 5 here, y e y squared plus y squared, right? dy plus c. Or simplifying it further, we have 5 y e 2y squared dy plus c. Okay. So from there, we can now integrate. But if you could look at here, okay, so you could say that, sir, can we use integration by parts? Look, here you have y squared. If we use this one as u, we could get du, that is y. So therefore, we don't need to use integrating by parts, integrating by parts. So let's just use the u of this one, that is 2y squared. Okay, sorry, that is not 2y. Yeah, it's correct, 2y squared. Okay, then your du is 2y squared. Okay, your du is 2 times 2, that is 4y dy. So your dy will just be equal to du over 4y, right? Now we just substitute it here. So x e raised to the power of y squared equals 5 y e, this is your u, then our dy is equivalent to du over 4y plus c. So from here, we could see we could cancel our y here. We could cancel our y here and this y. So what remains is just x e y squared equals 5 eu times du over 4 plus c. We can move the 1/4 outside the integral sign, so you have x e raised to the power of y squared equals 5 times 1/4, that is 5 over 4, integral of eu du plus c. Now, we know that the integral of eu is still eu, so therefore we have x e y squared equals 5 over 4 eu plus c. Let's continue up here. So we have x e y squared equals 5 over 4 e. What is our u? Our u is 2y squared over 2y squared plus c. Okay, we could divide it here. So we have x, divide both sides by e y squared. So we have 5 over 4 e 2y squared. Okay. 2y then squared times divide, so sorry, that is, sorry, we have this one is div. let me erase first. Okay, so this is actually divided by this is actually divided by a raised to the power of y squared. Okay, so now divide this one with a raised to the power of y squared plus c over e y squared. So this one becomes, we could deduct that one, x equals 5 over 4 e 2y squared, then we have times e, we can do that one here, okay, we can do that one times, times e, then you have negative y squared plus c over e y squared. So here we could now, or you just simply divide that one. So you have y equals 5 over 4 e, that is 2y squared minus y squared, that is only y squared, right? Plus c over e y squared. So let c sub 1 be equal to c over e y squared. So therefore your x will be equal to 5 over 4 e y squared plus c sub 1. So therefore this is our general solution. This is our general solution. Okay, let's check. Okay, so let's check here. This is our guide. Okay, so to confirm, we have 2y, 5ey squared, ey squared, and our general solution is this one. Okay, sorry, some difficulty. We're experiencing some difficulties. Okay, so 5 over 4 ey, and you could see this one. So 5 over 4 ey squared plus c. So we also have that one. 5 over 4 ey squared plus c sub 1. Okay, so that's it for this example. So we'll have another example which is a lot longer. We will be using your old topics in integral calculus, especially the one I've talked, the integration by parts. Okay, so okay, let's try.